My dear students, in this video also I am going to solve some problems in first order linear differential equations. In the previous video I introduced what is meant by first order linear differential equation and how to solve those equations we have seen. On the continuation of that video, in this video also we will solve some more problems. First order linear differential equations. Linear differential equations. Solutions of these equations. First problem, solve dy by dx plus 2y cot x equal to dy by dx plus 2y into cot x equal to 3x square into cosecant square x. So this is the form. This equation is of the form dy by dx plus py equal to q. What is p? Y coefficients are p, except y, 2 cot x is p here. So p is, instead of except y, 2 cot x, because py, 2 cot x into y, therefore p is 2 cot x. And what is q? Q is 3x square into cosecant square x. Our first step is to find integral p dx. To solve, our first step is to find integral p dx, that is equal to integral p is 2 cot x dx. You can take the 2 out of the integral cot x dx. Integral cot x is log sin x, therefore this is log of sin x. Integral cot x is log sin x. By the definition of logarithm, this 2 log becomes log sin power 2. That is log of sin x power 2 or log sin square x. This is nothing but log of sin square x. Log sin x square is log of sin square x. Our next step is to find out the integrating factor. Integrating factor is e power integral p dx, that is equal to e power log of sin square x. Exponential logarithm or reciprocal functions, you will get only sin square x. E power log is 1, you will get only sin square. So integrating factor is sin square x. So we have determined second step also. Integrating factor is sin square x. Now our solution. Therefore, the solution of the equation is, y into integrating factor equal to integral q into integrating factor dx plus c. Integrating factor is equal to integral p dx. That is y into sin square x equal to integral q is 3x square into cosecant square x into integrating factor is sin square x dx plus c. Okay. Cosecant square and sin square are reciprocal functions, they get cancelled each other. Cosecant square and sin square are cancelled each other because cosecant square is 1 by sin square. These two get cancelled, you will get only 3 you can take out of the integral, you will get x square dx only. Because cosecant square and sin square on product you will get 1. 1 into 3x square is 3x square, you can take 3 out of the integral, you will get x square, the integration is x cube by 3. Here you have 3 into x square, integration is x cube by 3 plus c, that is equal to 3 cancel, you will get x cube plus c. So y into sin square x equal to x cube plus c. This is the solution for the given differential equation. Y into sin square equal to x cube plus c is the solution, general solution for the differential equation. Next problem we will see another problem. Solve next problem solve x square plus 1 into dy by dx, x square plus 1 into dy by dx plus 2xy equal to root of x square plus 4. You consider this problem. X square plus 1 dy by dx plus 2xy equal to root of x square plus 4. You rewrite this equation as dy by dx plus dy equal to q form. For that, you divide the entire equation by x square plus 1. You will get dy by dx plus 2x by this x square plus 1. X square plus 1 into 2xy is 2x by x square plus 1 into y equal to root of x square plus 4 by this x square plus 1. So, entire terms should be divided by x square plus 1. You will get dy by dx, x square plus 1 cancel, 2x by x square plus 1 into y equal to this root of x square plus 4 by x square plus 1. Now, the coefficient of y, 2x by x square plus 1 is p. What is p for this equation? It is for the form dy by dx plus py equal to q. dy by dx plus py equal to q. Therefore, p of this equation is 2x by x square plus 1. And what is q? Root of x square plus 4. Root of x square plus 4 by x square plus 1 is your q. Now, our idea is, first we have to find out the first step. P is 2x by x square plus 1 and q is root of x square plus 4 by x square plus 1. And now, first step is integral p dx. That is, integral p dx is integral 2x by x square plus 1 dx. So, log of the denominator is the numerator. The derivative of x square is 2x and the constant derivative 1 is 0. Therefore, just x square plus 1 derivative is 2x. It is in the numerator. Therefore, integral f dash of x by f of x dx form. Integral f dash of x by f of x. The derivative of the denominator is in the numerator. The answer for the integration is log of the denominator. Log of x square plus 1. That's all. Next step is integrating factor. Our next step is what? Integrating factor. Integrating factor is e power integral p dx, that is equal to e power log of x square plus 1. Exponential logarithm or reciprocal functions. Therefore, e power log is 1. You just get x square plus 1. That's all about the integrating factor. For integrating factor, e power log is 1, you will get x square plus 1. Therefore, the solution is y into therefore the solution is y into integrating factor equal to integral q into integrating factor dx plus c. Now substitute the expressions you have derived so far. Y integrating factor is x square plus 1 equal to integral q. Q is x square plus 4 by x square plus 1 into integrating factor is x square plus 1 dx plus c. So x square plus 1, both numerator and denominator we have, they get cancelled. So these x square plus 1, both the numerator and denominator cancel, you get just x square plus 4 only. Square root of x square plus 4, dx plus c. So, you remember, if this integral is of the form, when you have one formula, integral root of x square plus a square dx. Integral root of x square plus a square dx equal to x by 2 into root of x square plus a square plus a square by 2 into log of x plus root of x square plus a square. That's your formula for this integration. Integral root of x square plus a square dx is x by 2 root of x square plus a square by 2 into log of of x plus root of x square plus a square. A square is 4. Now you use this idea here. X square plus 4 is x by 2 into root of x square plus a square is 4 plus a square by 2. A square is 4. 4 by 2 into log of x plus root of x square plus 4 plus c. That's all about using that result. Root of x square plus 4 dx is entirely a square is 4. X by 2 into root of x square plus a square plus a square by 2 into log of x plus root of x square plus 4 plus c. So that is, the solution is, right hand side is y into x square plus 2. Therefore the solution is y into x square plus 1 equal to x by 2 into root of x square plus 4 plus 4 by 2 is 2 log of x plus root of x square plus 4 plus c. That's all about the answer for this problem. This is the it's a general solution for this problem. That's all. This is the second sum. This is the general solution for this problem. Next problem is second sum. You have solved. Now the third problem I am going to solve. One more problem. Third one is solve dy by dx. The problem is dy by dx plus y by x log x. So this problem is, third one is dy by dx plus y by x log x. dy by dx plus y by x log x equal to sin 2x by log x. This is your problem. dy by dx plus y by x log x equal to sin 2x by log x. It's also a linear differential equation in the form dy by dx plus py equal to q. Y except y, the coefficient 1 by x log x is p. For this problem, or p idea, from this expression I will get p equal to 1 by x into log x. This is p. Q is sin 2x by log x. Sin 2x by log x is q. So first step is integral p dx. Our first step for this finding the solution integral p dx is our first step. That is equal to integral p is 1 by x log x dx, and this expression can be expressed as this 1 by x by log x. You rewrite this integral as 1 by x log x is 1 by x in the numerator by log x. Again, derivative of the denominator log x derivative is 1 by x is in the numerator. Derivative of log x is 1 by x, which is in the numerator. Therefore, integral f dash of x by f of x form. Therefore, the integral value is log of the denominator, log of log x. That's all. This is integral p dx. Now integrating factor is e power integral p dx equal to e power log of log x. Log of log x. So exponential logarithm or reciprocal function c power log is 1. You get log x is your integrating factor. That's all. The solution is, now the solution for this problem, y into integrating factor this is y into interacting factor equal to q into interacting factor dx plus c. Now for this problem also, y into log x. This integrating factor for this problem is y into log x equal to integral q. What is q? Q is sin 2x by log x. Integrating factor is again log x. Integrating factor is also what? Log x into dx plus c. Here denominator numerator log x cancelled, you will get sin 2x dx only. Sin 2x dx plus c only. Integral of sin 2x is minus cos 2x by 2. Integral of sin 2x value is, integral of sin 2x, you know, minus cos 2x by 2 plus c. You know the integral value of sin 2x is minus cos 2x by 2, and you bring this minus cos 2x by 2 to the left hand side, you will get the solution is, therefore the solution is y into log x plus y cos 2x by 2 equal to c. Y log x plus cos 2x by 2 equal to c. That's all about the problem and the solution for this problem. This is the general solution for this problem. And finally, one more problem I am going to solve. Fourth one is in this problem, you consider the problem. So tan inverse y minus x. Tan inverse y minus x. Tan inverse y minus x into dy. Tan inverse x, tan inverse y minus x into dy equal to 1 plus y squared dx. 1 plus y squared dx. So this is, it's somewhat different problem. Instead of x and y roles are interchanged in this problem. So far we have seen dy by dx plus py equal to q form, but in this equation the x and y roles are interchanged. For that, this equation can be expressed as, listen, tan inverse y minus x, tan inverse y minus x, by you bring this 1 plus y square to the left hand side, it comes to denominator equal to dx by dy. You rewrite this equation as dx by dy equal to tan inverse y minus x by 1 plus y. Here in this problem, the x and y roles are interchanged. It is not as in the previous case. Now you rewrite this equation, you split this as dx by dy. Dx by dy, the left hand side, sorry, you keep that expression on the right hand side is dx by dy, and you take that minus x by 1 plus y square to the right hand side. It becomes plus x by 1 plus y square equal to, left hand side you have tan inverse y by 1 plus y. You rewrite this equation like this. You keep at dx by dy as it is, and you bring minus x by 1 plus y square to the right hand side, it becomes plus x by 1 plus y square, and keep it as in the equation as dx by x plus 1 by 1 plus y square. And the left hand side you have tan inverse by 1 plus y square. You rewrite this equation like this. So this is of the form dx by dy plus px equal to q. This equation is of the form dx by dy plus px equal to q. Here x and y roles are interchanged. It is not in the form dy by dx plus py equal to q. It is dx by dy plus px equal to q. The roles of x and y are interchanged. Now p value is, in terms of y you have, p and q are functions of y. P is 1 by 1 plus y square px, except x, p is 1 by 1 plus y square. So p is 1 by 1 plus y square. P is 1 by 1 plus y square. What is q? Tan inverse y by 1 plus y square. Q is also in terms of y only. It's a function of y. Tan inverse y by 1 plus y square. So this is P, 1 by 1 plus y square, and Q is tan inverse y by 1 plus y square. Now our first step is not integral p dx, it is integral p dy. X and y are interchanged. Roles of x and y. Integral p dy is integral p 1 by 1 plus y square dy. You know 1 by 1 plus y square integration value is tan inverse y. Okay, that is integral p dy. Now the integrating factor, second step. Integrating factor is, second step is integrating factor, that is e power integral p dy, that is equal to e power tan inverse y. Therefore the solution is x into integrating factor. X into integrating factor plus integral q in x into integrating factor. X and y roles are interchanged. Therefore the solution is x into integrating factor equal to integral q into integrating factor dy plus c. Now x into integrating factor is, what is that? E power integrating factor, what do you get? E power tan inverse y. This is one integrating factor. Therefore x into integrating factor is e power tan inverse y equal to q is what? Tan inverse y by 1 plus y square. Q is tan inverse y by 1 plus y square into integrating factor is e power tan inverse y dy plus c. Now to solve this right hand side integral, you give a substitution for tan inverse y. Tan inverse y, give a substitution t for tan inverse y. So dt equal to tan inverse y is 1 by 1 plus y square dy. If you give t for tan inverse y, dt is 1 by 1 plus y square dy. 1 by 1 plus y square dy is dt. This 1 by 1 plus y square dy is dt. Tan inverse y e power tan inverse y is t e power t. So the problem, after giving the substitution, you will get x into e power tan inverse y equal to integral tan inverse y is t e power t. 1 by 1 plus y square dy is dt plus c. That's all about the problem. After giving a substitution for tan inverse y equal to t, the integral becomes x into e power tan inverse y equal to integral tan inverse y is t, e power tan inverse y is e power t, 1 by 1 plus y square dy is dt plus c. It is 1 by 1 plus y square dy is dt plus c. Now x into e power tan inverse y equal to t e power t. You consider u is t, du is dt, and dv is e power t dt. Therefore, v is after integration you will get only e power t. So this is the form integral u dv form. U is t, e power t dt is dv, u dv is uv, u is t, v is e power t, uv minus integral v e power t, du is dt plus c. Okay, so that is x into e power tan inverse y. Left hand side nothing change. X into e power tan inverse y equal to t e power t minus integral of e power t is e power t plus c. Now you take t as e power t as a common term, you will get t minus 1 plus c. Now you replace t by tan inverse y. Therefore the solution is, I am erasing the problem. Therefore the solution is last step. Therefore the solution is x into e power tan inverse y equal to, replace t by tan inverse y, e power tan inverse y into t is tan inverse y minus 1 plus c. Now divide throughout by e power tan inverse y, you will get x equal to, divide throughout by tan inverse y, you will get x equal to, solution is e power tan inverse y into e power tan inverse y can get cancelled. If you bring this to the right hand side, it becomes e power tan inverse y by e power tan inverse y. You just tan inverse y minus 1 and plus c into e power tan inverse. This denominator you divided by each term by tan inverse y plus c into e power tan inverse y. You divide by c by e power tan inverse y, that is e power minus tan inverse y. That is c into e power minus tan inverse y. That's all. You bring this e power tan inverse y to the right hand side, it becomes, this two cancel, you will get c into e power minus tan inverse y plus c. That c can be multiplied divided by e power tan inverse y, it becomes c into e power minus tan inverse y. That's all about the problem. This is the general solution for this problem. Okay, thank you. We will continue in the next video.